Hi, and welcome to Networking Fundamentals. In this course, we are going to cover a lot of different concepts in network fundamentals. This is kind of an intro class, and it's preparation for your Network Plus test if you're taking it through CompTIA. This class is going to follow along with the book pretty consistently. So I actually would recommend, as you're watching the lecture videos, go ahead and have the book open and kind of flip through it while I'm describing the different concepts. Hopefully these lecture videos will help you to cement the knowledge that you're going to learn through reading the book. I have a roadmap that I'm going to be following through the book, which is just going to cover the different chapters, but helping you to understand where you are in the course as we get forward and closer to preparing for the exam. There are 20 chapters in the book, so there should be roughly 20 lectures. And we're going to start today with just introduction to networking. What is networking? Why would we do it? I understand a lot of you will already know this. That's okay. Review is always good. And sometimes there's some words that you may have missed because you learned it on the job rather than learning it through a classroom. After our introduction, we're going to jump into different types of media. So media is going to be your copper, your fiber optic, and your wireless, different ways of being able to transmit data. Then we'll talk about some operating systems, so our network operating systems. We'll get into how things get transmitted using the addressing options. We'll get into subnetting in that one. Then we'll talk about some alternate access options, so different services, web services, and remote access. The last couple of chapters are going to be on administration. So how do you administer? How do you take care of your security? And then finally, we will have a practice test and talk about different job options that you have. Hopefully this class is really interesting for you and you'll have a good time. So starting with chapter 1. Chapter 1 is going to cover our introduction to networking. We're going to talk about different definitions and options that you'll have. Let's get started. So what is a network? A network, in a very small, simple way, is simply computers, equipment, and devices that are connected to each other. So you can have a network without really realizing it if you have your home router connected to your laptop, which is also connected to your phone. You have just built yourself a network. It can get very large from there. So those would be really small ones. But in theory, you have your computer devices, so your PCs or your laptops. You have your peripherals like your printers or your fax machines or anything else that is going to have file servers, print servers, things like that that are going to be attached. And then we have all of our other little things like our phones or our cell phones or even the cameras and different options that we have. All of these can be built into a network. Networks have some good things and some bad things about them. The fact that they can share software, they can share their data, they can share communication is great. As you know, if you've got a old printer that is connected directly to your computer and the other computer in your house can't see it, that's kind of irritating. Having one networked printer is nice. You only have to buy one printer. You can buy a nice one like a laser printer and everyone in the house can use it. So there are some benefits of sharing your equipment. You can have the security options of having a network. So creating your network with secure data between them, you'll understand that your data is going to stay secure. And then, of course, it can be less expensive. You only have to buy certain equipment once instead of buying it multiple times, and you can share information. Of course, there are always some disadvantages. Sometimes it takes access personnel to come in and set up your network, especially in a business environment. You want to hire someone, i.e. you want to hire somebody, businesses want to hire somebody to come in and set up your network. That's an extra cost. If the network goes down, you suddenly don't have access to any of those things. That's a negative as well. And then, of course, there's the basics of vulnerability. If your security is not set up correctly, you can have cyber attacks or even disgruntled workers from inside a company that can affect your network. Somebody gets upset that they're getting laid off and they can make choices that are going to damage your network. So these are some good and some bad things about a network. That being said, networks are the way things are going. There isn't any companies that I know of that don't integrate some semblance of a network in their business. You need to have it. You need to have things connected. Even with this new day where everybody is working from home, we're still accessing things on the network because we're still using virtual machines. We're still using remote desktop. So lots of things going on with the network. Here we're going to discuss the different classifications of a network. These are kind of guidelines as opposed to hard and fast rules. Sometimes a LAN can grow into a wide area network, but we'll still call it a LAN. We can start with a personal area network, which turns into a LAN. Things can kind of have a little bit of fudge factor. Basically, we're going to talk about the top three, which are going to be a local area network, a metropolitan area network, and a wide area network. So generally, a local area network is confined to a single building and it's managed by a single entity. It's possible if you have two buildings that are right next to each other, we can call that one building and it can still be a local area network. But in general, it's the managed by a single entity concept. A lot of people will refer to their LAN or their local area network, and it could have 10 buildings that go across it. That's fine. It isn't really hard and fast calling it a LAN or a MAN or a WAN. They all kind of work together. Technically, a metropolitan area network, or MAN, is at least two different LANs connected together, still kind of in the same area. So if you can imagine having a building on the west side and a building on the east side, and they both need to talk to each other, they can have their own individual LANs for their local building and then connect them with a hard line between the two, or a dedicated connection between the two, and that's going to give us a metropolitan area network because they're on two sides of the same city, but they're in two technical buildings. And then, of course, there's a wide area network, which can be many networks connected together. You could say that in theory, the internet is the largest WAN that we have because everything is connected. Taking that down a level, we can create a personal area network, or a PAN, which is simply centered around a single machine or a single person. So this would be your laptop connected to your desktop, connected to your home network, connected to your printer, your phone, and your watch. That's your personal network. You could technically call that a LAN if you have multiple computers in there, but in general, that's all things having to do with just you. We can also have a campus area network, which is kind of that middle ground between a metropolitan area network and a large campus, like a college campus, where you have multiple buildings, but they're bigger than an individual LAN because they can kind of be bigger than that, more than one building. There's lots of them. You could have 20 or 30, but they encompass just a single campus. And then, of course, the global area network. This is obviously the internet, multiple countries, multiple references. So lots of different ways that we can classify, but try to think of them in terms of how many people are maintaining them, how much space do they encompass, and do they cover multiple geographic regions. So if you can have the same region, you're talking about a personal area network, maybe a campus, a local area network is the kind of overall, and then a metropolitan. Those are all kind of in the same geographic region. Whereas your wide area network and your global area network are going to be more larger across multiple locations. When we build our network, we are going to have a network topology. Topology is going to describe how are things built together. How can you see them? This is in a visual sense. This does not mean that your offices have to be set in a star location. It simply means that there is a center location when there is a star, and so on and so forth. So we're going to start first with our bus topology. This is going to be kind of your basic backbone. It is a single main cable that runs through and everything hooks into it. It is a backbone. It is a single line that is going to describe, or that everything is going to attach into. Our next one, if we go down, is going to be our ring topology. As you can see, this is in a ring. Each computer is attached to two other computers on either side of it. So the ones that are directly across from each other are not directly connected, but they can get to each other by going around the ring. So you go from your top to your left to your bottom, and that's how the bottom and the top can talk to each other. These can sometimes be referred to as a token ring, which we'll talk about later, and they can have what is called a multi-station access unit kind of in the center, helping to maintain that ring. Again, we'll talk about that a little later in this slide, or in this chapter. You can have a star topology, which is where we have a hub in the center and everything is connected to the hub. This is how a lot of original networks were designed as well, along with that backbone concept of being everything connected to a singular hub. It wasn't always the most efficient, but it worked, and it was a great way to do it. You have the hub in the middle. We've also found that there are ways to handle that to get them into different networks. You can have a hub or a star topology in a singular office where you have 5 computers that want to connect together or something like that. And that's fine. Remember, the computers don't need to be in this place. The cables don't need to be in this order. It's just when you look at it logically, this is how they're going to look. The other one we have is called a mesh topology. And this is kind of an option that you can have where everything is connected in multiple ways. You can have either a full or a partial mesh. So you have a mesh where 2 of the 3 are connected, but the 4th isn't connected. So it's a partial mesh. It's not all connected. Or a full mesh where every computer is connected to other computers. We'll talk about different reasons why you would do this, either a client server or peer-to-peer environment. We also have what we call hybrid technologies. So the example in the middle on the top where we have a ring, we have 2 stars, and then we have a backbone. So the backbone goes across the top. So we have our bus across the top. And then in that line, we have connected 2 star topologies and a ring topology. That's fine. You can totally do that. There's also the tree topology, which is kind of like a bus topology that has a bunch of stars coming off of it, kind of like nodes. Obviously, there's also a wireless technology, which doesn't have any cables at all. We'll talk about that more when we get to wireless. The important thing to visualize with this is those symbols. So you can see the symbols up at the top corners of each of the different topologies. You have to be able to see that symbol and know what it means. So if you saw the square with the X through the middle of it, you would know that that is a full mesh topology. You can just see it. The one with a star, the one with a backbone, recognizing the bus topology is the one with a straight line with multiple nodes coming off. Keep those symbols in mind because they're going to help you, especially on the exam, remember which one's which. Obviously, this is also how we draw them when we draw out our topology. There are 2 basic kinds of administration when we have a network. You can have a centralized or a decentralized administration. So starting with a centralized, this is where we have a client-server relationship. We call it the client-server model. And it's very centralized, meaning that there is a singular location that administers it. There is a network administrator or an administrative server that is going to be the center location for all of this. You can have in this location a singular hub that connects in all of your devices. As long as that server is the thing keeping track of it and keeping it all centralized, that's fine. In this type of model, you can have a dedicated server. So you can have a main server that covers everything that you need, and then you can break down that server into multiple servers where each server has its own thing it's doing. So we have our file server. So with a file server, obviously, holding on to files, keeping track of all your data, keeping that all together. You can have a database server, which stores your database for your SQL Server, your Oracle database, which is separate from your administrative server, which is the thing that manages all of your logins and your permissions and all of your security things in your admin server. And then, of course, you can have a print server, where it keeps track of all your printing nodes and all your printing options all in that server. So you can have multiple servers in a client server as long as you have a centralized administration. In the peer-to-peer model, everything is decentralized. So peer-to-peer, meaning everybody's equal. All the computers, all the different ones are equal. They can talk to each other. There's no one managing everybody. We're just going to hook them all up and they can all talk to each other and they're fine. This is probably how you have your house set up if you have multiple computers in your house. So if you have a singular router that you're all connected to and you have, 2 adults, 3 children, and they all have their own computers, however you have it set up, those are all usually in a peer-to-peer network and you don't have a dedicated server just for your administration. Usually peer-to-peer servers or peer-to-peer models are usually less than 25 computers because after that it starts to get ridiculous trying to keep things straight. But in this case, peer-to-peer, every computer controls their own resources. So I could choose on my computer to say, I don't want to have anybody see this folder or this file. I don't want to share anything. Whereas my child's computer, I could have everything open and have everything available in that option. So each computer can control their own resources. The thing with peer-to-peer is it's a little less expensive. You don't have to have an admin to keep track of things. You don't have to have an admin server. There's no extra software to maintain. You just connect everything together and it's lovely. With the advent of the cloud is really, really useful and businesses are really flocking to this concept of using the cloud to maintain or store a lot of the stuff that they want to handle. There are technically 3 different types of cloud computing that we're going to talk about in this course. We have our software as a service, which you may have seen the acronym SaaS with the S's being capital, the A's being lowercase. This is where a specific application is in a virtual manner. They're stored in the cloud. So on some cloud server somewhere, they're not stored locally on your local machine in your local office. They're stored in the cloud. This is where your software is kind of on demand. If you've ever used QuickBooks online or your online banking or anything that's kind of an online service that you log into through the web or log into through LogMeIn or any of the secure browsers, you can use the software from a virtual environment and not have to have anything local on your machine. This decreases a huge amount of overhead just because you don't have to store anything on your local office anymore. So software as a service is just a specific application. A platform as a service. So this is an entire platform. This is an operating system similar to the way that we're thinking about having an application, but you can have your whole OS. You can choose to have a platform as a service either as a public cloud or a private service within your individual network. So you can have a dedicated server cloud designed as a cloud in your network, setting up this platform, which is still somewhat separated, but it can be still within your network. If you have a local area or a campus area network, even with a wide area network, you can choose to have your platform within your network to keep it secure, but still give you the freedom of having your operating system treated like a software as a service on demand. The last one that we have here is an infrastructure as a service. Now, this is sometimes a little hard to differentiate between the infrastructure or the platform. The infrastructure is having all of your infrastructure bases in a virtualized manner. This can be your servers. This can be your print servers, your file servers, your database servers. They can all be your entire infrastructure all up in the cloud. Again, in that virtual thing, you usually use an infrastructure as a service straight through a virtual environment, and you use remote access to log in. So these are your different three. They all have the same format. You can see with their names: software as a service, platform as a service, or infrastructure as a service with a different first letter. And they have that kind of lowercase a's in the middle, so you can reference them inside. Different types of clouds can be either public, private, or a hybrid of both. You can create a hybrid cloud that has some access available to the public and some access kept private. So I might want to keep my HR private or my financials private, but I might want to have my marketing be public because I want to have that available to the public, but they're all inside the same cloud. So that would be a hybrid cloud that uses both different cloud options. We're going to talk further on network operating systems in around chapter 10. But network operating systems is how the different devices, nodes, are going to communicate between your printers, your hardware, and your computers all on the network. So understanding all of those different things are going to be in an operating system similar to your Windows or your Mac or your Linux. We're going to have an operating system designed just for our network, and the network is going to handle all that communication. As you can imagine, we are going to cover protocols in depth as we go along, but we do want to give you kind of an overview of some of the protocols. Technically, a protocol is how do two devices talk to each other? How are they interacting? And we create a protocol, which is a set of standards that help devices talk to each other. That's all it is, set of standards. And those standards are going to describe you are going to do this, then you are going to do this, and this is how this is going to work. So we're going to talk about our different protocols that we use. You probably have heard a lot of these words already, especially if you've already worked in the industry, you might know a lot of these already. The most common that we're going to talk about is our TCP IP, which is our transmission control protocol, and our internet protocol. These are two different protocols, and they work in sequence together. These help with our transmission and help to understand how to move things from different layers of the OSI model, which we'll talk about in a couple of slides, but how data gets moved from being in a digital sense on your cable out to your application and all of the steps in between there. A couple of other protocols that we're going to cover is our network time protocol. This keeps track of what time is it. Make sure everybody's all on the same date and time. File transfer protocol, where you can send files back and forth. And our SMTP, which is our simple mail transfer protocol. Odds are, if you have an email and you are getting it on your phone or on your computer, at some point you have set up your SMTP protocol that you're going to be using. That is going to describe how things are going to get from your mail to your mail server and back down to who they want to go to. We are going to talk about ATM, which is asynchronous transfer mode. Asynchronous meaning they don't go at the same time, different times. This is used a lot for data and video, and we do use it for voice. It's usually the backbone of your ISP or your cable. We use this ATM back and forth. They are storing their packets in 53-byte packets, and we'll describe what that means when we get into packets. Originally, they went from 1.5 megabits per second up to about 600 megabits per second if you were really lucky. They're doing great now. We're greater than 2 gigabits per second. We're moving just fast, which is great because we like faster data. Our link layer discovery protocol is used to detect other devices on your network. So if you want to talk to another computer or another printer, another device on your network, you're going to use an LLDP to do so. There are unique LLDPs that we'll talk about when we get into our protocols on that, that are proprietary. They involve simply the company that created them. There's also the Microsoft OS protocols, the NetBEUI and NetBIOS. These were really the original Microsoft 3.1 NT versions of being able to do some networking. We'll talk about those when we get to our Microsoft operating system, but we still want to know about them because you never know when you go into a company what their protocol is going to be and how long it's been since they've updated. They may have been years since they updated and they may still be using these protocols, so understanding them. Now, protocols are technically data exchange. How are things going to be done? The protocol is going to tell us the size of the packets that we're going to do, how we're going to send them, how we're going to compress it. If there needs to be a signal at the end to say I'm done, do I need to keep track of this session? Do I care? And do I do any error checking to make sure you got all the data you were supposed to do? This is the type of information that you find in your protocol. So your protocol is going to help you describe which one you're going to do. Some protocols are going to require error checking, some won't. So when you set up how your protocol is being used, you need to know these kind of things. If you have worked in networking before, you probably have heard of your network address. Your network address is a unique identifier for a specific node on the network. So every node, every device on the network has a network address. The network address can be broken up into two different things that are really useful in keeping track of them. The first is your MAC address, or your media access control. By the way, we're going to talk about a MAC layer later, so keep track of the difference between the address and the layer. Media access control is a 6-byte hexadecimal number. It's the one that's at the top here circled. So there are 6 bytes of 48 bits of hexadecimal. Hexadecimal meaning they go up to 16. If you don't know what hexadecimal is yet, 0 to 9, and then A through F. So that's up to 16. So A would be 10, 11, 12, 13, 14, 15, 16, and you get up to F. So those are hexadecimal numbers. The cool thing about MAC addresses is that they break it up into 3 bytes that describe the manufacturer and 3 bytes that identify the card itself. So you are able to physically look at the MAC address and know who made it, which is kind of a nice thing. So we use 3 bytes for one, 3 bytes for the other. They're always split like this. So if you ever have a device, you can go look at your MAC address, look at the first three bytes, or the first 3 bytes, the first 6 hexadecimal numbers, and be able to determine who the manufacturer was of the device. So that's your MAC address. It is unique to every device everywhere. So the manufacturer takes care of the first 3, and inside that they take care of the next 3, and it comes out to a lot of devices, so they're able to be perfectly unique. The second is what we call an IP address, and this defines where is it across the internet, across all of the different devices in the world. So our IP address, there is an IP4 and an IP6. We'll talk about the difference later. So for right now, the idea that we're just worrying about our IP4, which is a 4-byte, 32-bit decimal or binary number. So decimal numbers, usually it's 255, 0 to 255 for each byte, and there are 4 octets or 4 groupings of numbers. So 192, 168, 0, 251 is 4 groupings of an octet, or up to 255 in decimal. You can also have a port, which designates some information, the network, and a port that designates the node address. When you look at the IP address, it can be routable across the internet. It's important to reference the difference. When you just use a MAC address on a LAN, the interior of the LAN can communicate with all of the different devices by their MAC address because they all know them. They're all connected to the network. But you can't use a MAC address to get outside of your LAN. There is a way that the administration will keep track of. And again, these are things we're going to cover. This is just an introduction chapter that are going to describe how the MAC address is used within a LAN and how we need an IP address if we want to get out to the internet. So going out to the internet, you need an IP address. If you're staying inside your LAN, you can do it with just a MAC address, and I'll keep track of that. Different ways to identify your node, your individual device on your network. At this point, we're going to talk about a couple of terminologies of devices. These are things that we are going to use throughout the chapters, throughout the different lectures to describe how they are used. But it's really important that you understand the difference between them and why they would be used in different situations. So the first is the word media. Media has nothing to do with what's going on in Hollywood or what's on the radio. Media is what we call the cables, the actual fiber optic or copper cables that connect things together. This is your media, your network media. And these cables are going to send electrical pulses, and we're going to talk about that when we get into our media discussion. These are going to describe how to get the data from point A to point B, but this is the actual cabling that we're going to be talking about. There is a device called a media converter, which converts from one form of media to another. We can go from electrical signals to light if we're going into fiber optic. We can go into waves if we're going into wireless. We need to convert from one to the other. So this is a converter. It converts media. In most of your computers, you are going to have something called a network interface card, or NIC. This is going to be something that is going to define your computer on the network. You are going to plug into or attach through your NIC. You can have a wireless NIC, or you can have a hard-coded NIC with an RJ45 or something like that attached to it. So this is your network interface card. This is how the device is going to interface with the network. It has to have it. These NIC cards usually have a driver. The newer computers are plug and play, so they probably already have it installed, but there is a driver that has to be included with that. We have what's called a repeater. You're going to hear the phrase attenuation multiple times in this course. Attenuation is what we call the loss of signal strength. As data goes through your cables, sometimes the signal gets weaker. That's called attenuation. How weak does it get as it goes along? Can we still read it? Can we still understand it? What a repeater does is amplifies it. It takes the incoming data stream and it just makes it louder, bigger, makes it bigger in the data stream. So it amplifies it so that it doesn't lose that signal and that attenuation is recovered. In the center of any network, you might have something called a hub or a concentrator. This is the central connection point for your network. This is where devices are going to go together. Now, we can break networks into subsections, which we'll talk about in a second. But in a small network, your hub is the center of it. We can also call it a concentrator. You can have both a passive or an active hub. A passive hub doesn't have any power. It just connects from the network and it moves along. An active hub can act as a switch, and it can be both a repeater and a hub because you plug it in. So it has power. So we plug power in, and that power is going to use the same concept that's used in a repeater inside of your hub. We like to combine things here. When we want to get from our location out to the internet, we use what's called a gateway. Now, you can have a router and you can call that your gateway because your router gets you out to the internet, but think of it as a gateway connects you to the internet, connects your LAN outside. That's important. You can have routers that do not connect to the network or to the internet directly, and they're not gateways. Your gateway is what connects you to the outside world, out to the internet. The last three are different types of devices that we're going to use inside to kind of build our network. We can use a bridge. So a bridge divides your network into segments, recognizing a hub does not divide it into segments. It's just a concentrator. A bridge divides it into segments, and it can help control your data, control your traffic going on in your network. If you want to have multiple groups of people and you want to have your HR department, your sales department, and your engineering department, they all want to work in different segments, you can break them up with a bridge and you can separate them. A switch, which is similar to a bridge, also creates subnetworks, yet it can also filter your traffic. So it can limit what traffic moves on between switches. So we like switches, they're useful. Again, all of these are going to get covered again. Just want to make sure you have an overall view of them. You can have a multi-layer switch, which can also look at the packet content and make decisions based on the content. A regular switch can filter your traffic based on the IP address that's being sent or something like that, but they don't look at the actual data. A multi-layer switch looks at your data. It actually inspects the content and figures out where to go from there. And finally, we have our router. Our router navigates packets across the network. So again, it doesn't have to go out to the internet. This is just within your local LAN, your local network. It can navigate how packets get from one point to another. So this is a way to get something from one subsection to another subsection, so large networks. Under the router, there is also the concept of a B router, or brouter, if you want to go with that, which is a bridge and a router together. So a B router takes the bridge ability to divide the network into segments and try to control that traffic along with the navigation in one device. Like I said, we like to combine things. Standards are generally a set of recommendations or practices that an organization builds that just defines how we're going to do things in certain aspects of technology. There are a lot of different organizations involved in building the internet as we know it today. Some of them started a long time ago. Some of them just started a couple of years ago, couple being like 20. We start with the IEEE. So the Institute of Electrical and Electronics Engineers. IEEE is a very important organization for networking. They actually began in 1884, back in the 1800s, which is great. And they build all of the standards that are going to start with an 802 prefix. We're going to talk about our different standards as we go along, and you're going to memorize a couple of these standards. The 802 prefix ones, especially relating to different types of networking and communication. They cover a lot of the industry, and they just set up the standards and everybody just kind of follows them. They are the group that makes the networking standards. The ISO, International Organization for Standardization, started right after World War II. Different organizations and countries got together and built the ISO. The ISO came up with what we call the OSI model, which we are going to talk about in the next slide. The OSI model is going to describe how data interconnects through the internet. The World Wide Web Consortium, or the W3C, was just started in 94 because if you're old enough to remember, before 94, we didn't really have an internet with like HTML or any type of HTTP. Things didn't work that way. So they take care of a lot of our web standards. W3C is our World Wide Web. So you can see that it's going to be web-based. So these are our web standards, our HTML, our CSS, our XML, and our HTTP. So these are web-based concepts. TIA is the Telecommunication Industry Association. They are from 1924, so they've been around for a while, but they are going to keep track of your fiber optics, your networks, your equipment, your wireless, and your satellites. So they're keeping track of what you might consider telecommunications, telephones, telegraphs, and now we're into fiber optics and copper cabling, making sure that the wireless and satellite, everything all kind of works together. The last standard on the list is going to be our ANSI, which is our American National Standards Institute. This was in 1918. They are technically a private, non-profit organization, and they don't actually build any standards, but they come up with some rules, and they kind of just go, we recommend you guys follow them. And we just leave it at that. They encourage what they call voluntary conformity. We really encourage when you use things that you use the standards that we've created. So you are going to find ANSI comes up a lot as well. This is just a standards organization that isn't formalized. It's not like the FCC. They're not going to come and yell at you, but they are going to say, this is what we recommend. And a lot of people do. So I've mentioned a few times the OSI model. The Open Systems Interconnection Model, it's the OSI model, describes how the hardware and the software should work together inside of a network. Originally, the Department of Defense built a 4-layer model. They said, okay, we're going to have the network interface at the bottom. Cool. That's going to connect to the media. We'll be fine. We're going to have our internet. We're going to have our transport layer. How is stuff going to get around? And then our application layer connecting to whatever application is going to connect to it. The original Department of Defense used basic phone lines. They used ASCII text with no graphics, no sound, no animation. And yeah, it wasn't what we have now. They didn't have to worry about security. They didn't have to worry about a lot of things because the only people using the system were the Department of Defense and a couple of universities. And that was it. Nobody else was in there. So they didn't worry about things like security or multiple sessions and having to worry about a lot of things. They just went straight from transport up to application, and it was fine. And how are we going to connect to the devices at the bottom? And we're good. That didn't work for very long. Once we got into the 80s and the 90s where things started really going along, they had to make something better. And so they built what they called the OSI model based on the original DoD model. This one has 7 layers. You will memorize these, by the way, and you will understand how they all work. This is a big part of this class. So the OSI model is something, if you are taking notes right now, write this down because you are going to have to remember it and you're going to have to come back to it. The OSI model was designed to increase the security and be able to work with multiple digital options, such as the audio and the visual and the video and the graphics. There are, like I said, 7 layers, and we're going to go through each of those layers right now. But we're going to start from the bottom, physical. We're going to do our data link, network, transport, session, presentation, and then finally application at the top. When we think about layers, we are going to start from the bottom. So our physical layer is going to be layer 1. Application layer is layer 7. Remember that they go that direction because it's important to keep track of which layer number are you referring to. Again, we'll be talking about that both in homework assignments and then in future lectures. Let's go talk about these different layers of the OSI model and how they work together. On this slide, we're going to cover the first 3. So starting from the bottom, our physical layer. This is the layer that contains all the physical parts. This is your hardware and your cables and your connectors. This is your hubs or your amplifiers. They are things that deal only with data, getting data from point A to point B. They don't deal with any actual, how do you transport? They're just the physical aspect. These are things you can touch, which is kind of nice because a lot of the other aspects you can't touch. You can't physically, tangibly hold on to them. But your physical layer is all of the things like this, like the cables that you can see and touch. When we get into our data link layer, our data link layer is a special layer because it actually has 2 sub-layers. It is the only one of the layers that has 2 sub-layers, so you have to keep this one straight. Layer 2 is our data link layer, and it covers how is it packaged to be transported from network interface card to a network interface card or NIC to NIC. Inside of our data link layer are the 2 sub-layers. These are going to be your logical link control and your media access control. Remember how I said you were going to see MAC layer later? This is your MAC layer. This is not your media access control ID number that is on your device. This is the layer that refers to how to handle it. So our LLC layer, sub-layer, is going to take the content, it's going to put it in a frame. It's going to frame the content and the MAC addresses. It's going to make sure that you have reliability, error checking, and integrity. So it is going to make sure everything got to where it was supposed to go, and it kind of figures out how to frame the content. The MAC layer actually converts those frames into pulses. So the pulses are going to be what is going to end up going into your physical layer on your media. It's going to prepare it for the transmission. It's going to look for collisions. It's going to negotiate its speed, and it's going to do contention resolution. These are the things like your bridges or your switches or your wireless access point or your NIC, obviously, because we're transporting from NIC to NIC, so obviously the NIC is a part of this. So the devices that exist on data link layer, logical link control, LLC, and media access control. The devices on your DLL are going to be your bridges, your switches, your NICs, and your wireless access points. Layer 3, remember we're going up. So the next layer up. This is going to handle where is it going to go, what's the addressing and the navigating using IP addresses. So the IP protocol is at this layer. We're going to talk about different layer protocols as they come along. There are some layer 3 switches, but this is generally where your routers are going to be, because this is dealing with how is the data getting around. Where is it going, and figuring out what IP addresses. DLL, it's going to take that information and it's going to start to turn them into frames and breaking it down and sending it down through the media access control into the physical layer. But the network layer, layer 3, is all about figuring out how to navigate around the internet using the IP addresses, which is why the IP protocol is at this layer. Remembering that the IP protocol is at this layer is important. All right. Layer 4, again, going up. In this layer, we are going to sequence our data into packets. When data comes in, it's going to start from your application. It's going to go all the way down to the media. It's going to transfer over to the next guy, and it's going to come back up. So you're thinking about the idea of breaking up your data into packets. And then when it comes back up through the transport layer, it's going to reassemble them. This layer is information about how are things delivered, the order of it, and the integrity of the data, making sure the data stays safe. This is your TCP and UDP layers. These are the layers that are going to sequence the data into packets. Once they're in packets, they can go back down into layer 3 and get broken into where are they going, what's the IP addresses at layer 3. Layer 2, they're going to go ahead and get broken down into signals, and then layer 1 go on to the media. Layer 4 is where gateways exist. So the gateway that goes out to the internet. So the gateway is going to sit there, and we're going to make sure that we understand those as well. So those are going to be breaking it down into packets and reassembling at layer 4. Layer 4 is the TCP layer. Layer 3 is the IP layer, keeping track of which protocols exist at which layers. Layer 5, again, going up. Layer 5 is our session layer. In some situations, we want to have a set connection between two computers. We want to be able to have that connection stay open while we are transmitting data across. So if you can think about a voice over IP phone call or anything that is going to keep open remote procedure calls, we need it to stay open while we do the whole thing. So the session layer is going to keep that session connection between the computers open during the entire transfer of data. The authentication and authorization occurs at the session layer. We want to make sure you're the right person you're supposed to be at this layer. And it handles those protocols. We are going to talk more about our session control protocol, our SCP, as we get further, but this is the protocol that transmits information and understanding about the session. So keeping track of the session and the connection between the two. Think of a session as you make a phone call to a friend, and as long as the two lines are open, you have a session, you have a connection. Up one more layer. This is the presentation layer. So at the presentation layer, we want to make sure that the character code recognition is done and that everything is formatted correctly for the delivery. We haven't actually built our session. That comes in layer 5. But at this point, we're making sure all the data is good. We're good with all the data. It's happy and everything is good and packaged correctly. We'll talk about why the presentation layer came up as a necessary thing as we go along and talk about different protocols. And finally, layer 7. This is not your application. This is not your Microsoft Word. This is not your internet browser. This is what interfaces with those. So this is the layer between your browser and the actual network. It establishes communication between the two. So your application layer is communication between your browser, your FTP, your email, so on and so forth. This is where your SMTP, your mail transfer, your TLS, which is a security, and your LDAP, being able to discover your neighbor's protocols exist as well. They all exist way up at the top at the application layer. Your browsers and your FTP and your email, while they come in under this application layer, it's because they have a section of their code that communicates with the application layer. So don't think that Google Chrome is an application layer. It isn't. But it has pieces in it that do the interfacing with the internet, with the network, establishing that communication. When we talk about different devices, this is where it gets a little confusing. We have our 7 layers of our OSI model. We have 3 layers of device layers. So there's actually questions on the test that say, which layer does this device exist in? You have to make sure you understand the difference between layer 1, 2, and 3 when it comes to device labels, as opposed to layer 1 through 7 of the OSI model layers. Different types of things. Okay, so when we have devices, these are the different things that are connecting the devices that we're working with. Layer 1 devices, the data moves through the cabling, the hubs, or the repeaters, but it doesn't make any decisions. This is your physical layer with your hubs and your repeaters, but they're not doing anything. They're not checking anything. They're not making any decisions. This is your first layer. Your layer 2 devices. These are ones that make decisions based on the MAC address or the name. Remember how I said within a LAN, you can make decisions based on the MAC address without having to have an IP address? That's where layer 2 devices exist. So they deal with decisions that are based on your MAC address or your name. Layer 3 devices recognize that TCP, IP, and UDP protocol. They make decisions based on which protocol you're using. So different layered devices at different points. And you can see here, we've given a couple of examples. Routers exist at the network level. Switches exist at the data link level. NICs can be at both the data link level and the physical level, and then we got our physical level. And then gateways are up at 4 through 7. Being able to recognize the different layers and which place they are making those decisions makes a difference. The other little graph here has the different protocols and which layer of the OSI model they reference. You're going to be asked to know this. So that IP, ICMP, and ARP exist at the network level, TCP and UDP are at the transport level, and a whole lot of other ones exist kind of in that 5 through 7 section. Those are important, recognizing which protocol is in which session, or which section of the OSI model. Okay, hopefully that was a lot of information for your first chapter. Hopefully you went through the book while you were listening, so that's good. This is what I'd recommend for your assignments for this chapter. In the book, review questions 1 through 24. You are going to have to do those, turn them into me. There'll be a place in D2L. In your study guide, I recommend doing all of them. The study guide covers 1.1 to 1 through 15, and they are going to go back and ask questions about everything I just said. Hopefully this lecture and the slides are going to help you to remember that, but every one of these answers should be in the book. Lab activities. There are 2 activities in the lab book having to do with this chapter. They should be fine to do them at home with your home computer. There's just going to be a couple of questions just getting you started with understanding where things are. In D2L, I've built a study guide that you can go in and use. It's actually kind of a fun little project to let you do some like questions, and it's kind of like slides or note cards if you want to check some. They've got some little quizzes in there, which are kind of fun. And then there's the chapter 1 quiz. I have built a chapter 1 quiz. For your first chapter 1 quiz, I'm going to make you take it in the Respondus lockdown browser. Not because I don't trust you, but because I want you to get used to the idea of having a lockdown browser. If you choose to take this test, the Network Plus test, through CompTIA online, they will use a lockdown browser like this. They will have a camera watching you. It will make you a little bit uncomfortable. I want you used to that. You cannot look at your notes. You cannot look at your book. Get used to it. When you do your tests, you're going to be using this lockdown browser. You cannot flip through things. You can't look through the book, and you can't look at any of your notes. When you take the Network Plus exam, you have nothing. You bring in nothing. And I want you to get used to being able to answer these quiz questions without having to have any reference materials there. Okay? Hopefully this was a great chapter for you, getting you some basic fundamentals of networking. Chapter 2, we're going to start working on our copper cable, being able to understand how the different cables work and how to build them, how to cut them, how to put together your different connectors. So please come back next time. Remember, if you have any questions, please comment, let me know what the questions are, and I will do my best to answer them. Have a great week.